Welcome to Educator.com. Today we're going to start talking about polynomial functions, and we're going to begin with some review of properties of exponents. So recall that when you need to simplify an exponential expression, you need to write the expression without parentheses or negative exponents. Also recall that a monomial is in simplest form if each base appears only once, if there are no powers of powers, and all fractions are simplified. And recall that in a polynomial, the terms are monomials. Okay, first reviewing the concept of negative exponents. If a does not equal 0, and we have that limitation because we don't want to have 0 in the denominator, a to a negative power equals 1 over a to that power. So a to negative n equals 1 over a to the n. For example, if I had 1 over y to the negative 4, if I had y to the negative 4, I could rewrite that as 1 over y to the 4th. Now, let's look and think about why this would be. If you have something like x cubed over x to the 5th, that would actually give you x times x all over x times x and on 5 times. So if I go ahead and look at what that would be, I could cancel out these x's, the first 3, and I'd end up with 1 over x times x, or 1 over x squared. I could look at this another way. I could use my rules for dividing exponents of the same base. And those rules would tell me that what I need to do is take x to the 3rd minus 5. So I need to subtract the exponents. And this is going to give me x to the negative 2. Well, since these two are equal, these two must be equal. Therefore, 1 over x squared equals x to the negative 2. And that's why we say that these two are equivalent. A to the negative n equals 1 over a to the n. And remember, in order to simplify exponential expressions, you need to make sure that there are no negative exponents. And using this rule is how we get rid of those negative exponents. Okay, reviewing properties of exponents. Each of these is covered in detail in Algebra 1. This is just a brief review. The first property is the one that we just talked about, which is negative exponents. A to the negative n equals 1 over a to the n. The second property is a review of multiplying when you have exponents with the same base. So if you have exponents with the same base, such as x to the 3, and you're asked to multiply that times something like x to the 4, you would accomplish that by simply adding the exponents to get x to the 7th. Division, to divide exponential expressions with the same base. So I've got two monomials here with the same base. What I'm going to do is subtract the exponents. Again, with the limitation that a does not equal 0 because we cannot have 0 in the denominator, since that would be undefined. So if I had something such as y to the 4th over y to the 6th, this is going to give me y4 minus 6, or y to the negative 2. And today, again, I'm reviewing these, but we're also going to go on and apply the properties more to negative exponents than we did in Algebra 1. And you could further simplify this by writing it as 1 over y squared. Now, raising a power to a power. When you raise a power to a power, you're going to do that by multiplying the exponents. So if I have x to the 4th raised to the 2nd power, I'm going to rewrite this as x to the 4th times 2, or x to the 8th. And again, this works with negative exponents as well. If I have z to the 3rd raised to the negative 2 power, it's going to give me z to the 3 times negative 2, or z to the negative 6 power. So this works for negative exponents. Okay, parentheses. Recall that in order to simplify exponential expressions, we need to get rid of parentheses. So if you have something such as AB and that whole expression is raised to the m power, you can rewrite this as a to the m times b to the m. So if I have, something such as 3x and it's squared, I could rewrite this as 3 squared x squared, which would give me 9x squared. Again, parentheses, but now talking about division. If I have a divided by b all raised to the n power, I can rewrite that as a to the n divided by b to the n, with the restriction that b, since it's in the denominator, cannot equal 0. For example, if I have x over y raised to the 4th power, I could rewrite that as x to the 4th divided by y to the 4th. Finally, something raised to a 0 power. If I have a raised to a 0 power, it equals 1. However, we again have the restriction where a cannot equal 0 because this is not defined. So we don't work with that. Now, let's think a little bit more deeply about why this is true. So we're saying that a to the 0 equals 1. Why is that so? Well, it's simply because we've defined it that way to make everything work out and all the rules be consistent. And you can look at it this way. Let's say I have y cubed over y cubed. Well, using my rule of division that I just talked about, when I have exponents with the like bases, I could say, okay, this is y3 minus 3, or y to the 0. Well, I could also look at it another way. Y to the 3rd over y to the 3rd equals y times y times y, all over y times y times y. Okay, so now these cancel out. And what this gives me is 1 over 1, or 1. Now, to make everything work out and have everything be consistent, all these rules be consistent, what I'm saying is that these two are equal. And I used a rule here and a rule here, and I got these two different things. Therefore, these two things must be equal in order to be able to use all of these rules. So we say that a, or any number to 0 power, is 1. Now, applying these rules to simplify some exponential expressions. Recall that in order to be in simplest form, I need to make sure there's no negative exponents, which there's not, no parentheses, I've got parentheses, and no powers raised to powers. I have that, so I need to take care of all of that. So I'm going to start out by recalling that a to the m to the n, so a power raised to a power is equal to a to the m times n. So let's first get rid of these parentheses by saying that I actually have a squared to the 4th times b cubed to the 4th times c squared to the 4th times b squared raised to the 3rd power times c cubed to the 3rd power times a to the 3rd power. Now all I need to do is multiply these out, and this is going to give me, I've got powers raised to powers, so a to the 8th times b to the 12th times c to the 8th times 2 times 3 is 6, so that's b to the 6th times c to the 9th times a to the 3rd. Okay, so it's still, this monomial is still not in simplest form because I still have some bases that are duplicated here. Each base should be represented only once in the monomial. So in order to simplify this, I need to multiply. And what I can do is recall my rule for multiplication when exponents have the same base. So a to the m times a to the n equals a to the m plus n. So what I can do is say, okay, I've got a to the 8th power, and I have a to the 3rd power. So I'm going to add those exponents. I have b to the 12th power, and I have b to the 6th power. I'm going to add those. I have c to the 8th, and I have c to the 9th. So I'm going to add those. And this is going to give me a to the 11th, b to the 18th, c to the 17th. Okay, so this is now in my simplest form, and I accomplished that by getting rid of the parentheses and using my rule for raising a power to a power. So I multiplied each of these times its power, and then I found that I had bases represented more than once, so I multiplied the expressions that had like bases by adding the exponents. Okay, simplify. Here we've got parentheses, we've got powers to powers, and we have negative exponents. So I need to get rid of all that. First by applying the power to each term inside the parentheses. So this is going to give me 2 to the 8th times x squared to the 8th times y cubed to the 8th times z to the 4th to the 8th power times x to the negative 2, y to the negative 2, z squared, negative 4. Okay, simplifying. If you work this out, it took 2 multiplied by itself 8 times, you would find that you're going to get 256 for that one. Okay, now, here I have 2 times 8, that's 16. 3 times 8 is 24. Z to the 4 times 8, that is 32. And then here I have a bunch of negative exponents, x to the negative 2, y to the negative 2. Z to the 2 times negative 4 is z to the negative 8th. Now, recall that if I have a to the negative n, this equals 1 over a to the n. So in order to eliminate these negative exponents, I'm going to move all 3 of these into the denominator. This is actually, there's an error right here. Okay, let me correct that. This is z squared to the negative 2. So this would be 2 times negative 2. That is actually negative 4. So z to the 4th power right here. Okay, now I can further simplify by dividing. So recall that dividing with like bases, exponential expressions with like bases, you subtract the exponents. So I can do that here. This is going to give me 256 x to the 16th minus 2 times y to the 24th minus 2 times z to the 32 minus 4. Now I do my subtraction to get x raised to the 14th power, y to the 22nd power, and z to the 28th. And this is my expression in simplest form, and I can verify that because each base is represented only once, there are no powers to powers, and there are no negative exponents, and there's no parentheses. Now, this was kind of complicated, but I started out by applying the power, the exponents, to each of the numbers and variables inside the parentheses. And I multiplied using my rule for a power to a power, which is a to the m n equals a to the m times n. Okay, once I did that, I saw I had negative exponents, and I used this rule to move those into the denominator so they became positive. And then I had like bases, so I used my rule for division in order to further simplify, getting this as the final result. Okay, simplify. Here I have negative power, and I have items inside of parentheses raised to that negative power. Recalling this rule, if I have a over b all raised to a certain power, this equals a to that power over b to that power. So what I can do is I can apply this negative 4 to each, to the numerator and to the denominator separately. So this is going to give me a to the 3rd, b squared, x to the 4th, all to the negative 4th power, over x squared, y cubed, c cubed, all to the negative 4th. Okay, once I have that, I'm going to use my power to a power rule a to the m raised to the n power equals a to the m times n. Okay, so applying the negative 4 to each item inside the parentheses. And doing the same thing in the denominator. And then multiplying the exponents to get a, negative 12, b, 2 times negative 4 gives me negative 8. And then here I have 4 times negative 4 is going to give me negative 16, x, negative 16, x, negative 8, y, negative 12, c, negative 12. Okay. Before I go any farther and deal with the negative exponents, I first notice that I have some simplifying I can do because these two have the same base. Therefore, I can divide, and dividing will require me to subtract the exponents, dividing with like bases. A, negative 12, b, negative 8, x, negative 16 minus, and this is a negative, so it's minus negative 8. And now in the bottom, I just have negative y to the negative 12, c to the negative 12. Okay, so this is going to give me a negative 12, b negative 8, negative 16, and this is minus negative 8, so it's really plus 8. Negative 16 plus 8 is going to leave me with negative 8. In the denominator, I have y negative 12, c negative 12. Now, I have a lot of these negative exponents. Recalling the rule for negative exponents, a negative n equals 1 over a to the n. Therefore, if I move everything in the numerator to the denominator, those exponents will become positive. For the ones in the denominator, I have to switch those to the numerator for them to become positive. Therefore, I'll end up with y to the 12th, c to the 12th, over a to the 12th, b to the 8th, x to the 8th. Okay, so this is simplest form because I have no parentheses, I have no powers to powers, and I have no negative exponents. I started out by splitting the numerator and the denominator by applying this power separately to each. Then I applied the power to each item inside the parentheses to come up with this. Then I noticed that I had the x's, they had the same base, so I divided x negative 16th divided by x to the negative 8th to get this. And finally, eliminating these negative powers by using this rule and switching the items in the numerator and the denominator to get my simplest form. Okay. We're asked to simplify, and we have bases that are represented twice, and we also have negative exponents that we need to get rid of. So first I'm going to start out by dividing. So I have a, negative 3, and then that's going to be using my rule for division, am over divided by an equals am minus n. So negative 3 minus negative 4, b squared minus negative 3. You have to be careful with the signs with all these negatives. And then c to the negative 2 minus negative 4. Let's take care of these signs. This is negative 3. Negative and negative actually gives me plus 4. And this is 2 minus negative 3, so that is plus 3. And then c minus negative 4 is plus 4. So this gives me negative 3 plus 4 is just 1, so I leave that as a. b, 2 plus 3 is 5. And then c, negative 2 plus 4 is 2. So this started out looking very messy, but it actually, once you divided, it took care of all those negative exponents. Okay, that concludes this lesson of Educator.com on exponential expressions, and I will see you soon.